Alright, so this is question 24, the last one of the test review. So there's a lot of words here, but basically there's a little bit of differences, so they want to see if that league team A scores more runs. They want to test that. That is what we're testing. And there's reasons why they think that that might be true, blah, blah, blah. We don't really care. So we're going to open up our data in StatCrunch, and this is how many runs they've scored. And so we're going to go, we're doing side-by-side box plot, so we can just go to graph and box plot. We can highlight both of them, and we find the one that closely matches this. So League A right here has 3 outliers, and this one is the only one where League A has 3 outliers, so it's going to be that one. Does there appear to be a difference? Yeah, definitely looks different to me. This middle median part is a lot higher in A, so that's what we're going to say. Yes, League Park A has a higher median. Now we're going to explain why we can use the hypothesis test. Each sample has the same sample size. That doesn't really matter. Each sample is a simple random sample. Yes, that matters. It's not biased. Each sample is obtained independently of each other. One does not affect the other. Sample size is large. Yeah, that works. Each sample size is relatively small, though, to its population. It's kind of weird to highlight both, but yeah. So now we're going to do the hypothesis test. So we're talking about means here, and the reason why we know that is because our data is given to us in numbers, in whole numbers. If we were talking about proportions, it'd be in decimals or percentages, and never have we ever talked about standard deviation in chapters 10 and 11. So we're talking about means. And our null is always equal to, and then our test hypothesis is what we talked about earlier, that the common belief is that the results in League A scores more. So we're going to do the mean of League A is greater than the mean of League B. Find the test statistic. So what we're going to do is we're going to go to stats, and t-stats is where we find our means, and it's 2 samples. It's not paired because up here, when we were identifying the qualifications, we said that each sample is obtained independently of each other. That means it's kind of confusing because at first you think, oh, maybe the teams are playing each other and therefore they're dependent, but that's not what it says. It says, to test this claim, a random sample of runs scored by league team with and without their so since it says the random sample thing, where they get the one sample has no effect on where they get the other sample, so it's not necessarily teams that are playing each other. So we're going to go to t-stats, to sample with data. Sample 1 is League A, sample 2 is League B, and then we're going to change this so that it reflects this. And so if the mean of A and B are equal to each other, then if you subtract them, it equals 0. And if the mean of A is greater than the mean of B, then when you subtract mean of A minus mean of B, since this one's greater than, it'll be greater than 0. Click compute. Our test statistic is the same thing as the t-stat. And our p-value is right here with our p-value. And should we reject or accept? So if we go back to our notes, and we want to write down what our p-values are. So our p-value is the 0.013, and our a, or alpha, I mean, are, let's see, where did it tell us that? Right here, 0.05. And our alpha is definitely greater than our p-value, and so we're going to reject the null. And when we reject the null hypothesis, it's because there's sufficient evidence to conclude that the alternative hypothesis is correct. So now we're going to construct a confidence interval. So we'll go back to our data, and once again, we'd be in t-stats, to sample with summary, or with data, excuse me. I'm just going to click on options and edit. And I'm going to select confidence interval, and we're talking about 95, which is already the standard set. And so our lower and upper limits are right there. And then what does it mean? So our confidence interval, what that tells us is it's a guess, an educated guess, I guess, on what, in this case, what our mean is going to be. And so we're saying we're 95% confident that the true mean, the population mean, is within these two numbers, is somewhere in between here. And so if you remember, our null hypothesis, and not just our mean, sorry, the difference of the two means is in between here. And so when we were identifying our hypotheses up here, and when we put it in here, we said that the null hypothesis is this minus that equals 0, and that this would be greater than 0, right? And so if we look at what our limits are, 0 is not contained in this, in these limits in our 95% confidence interval. And so therefore it does support what we've been saying, is that we are going to reject that null hypothesis, that the difference between the two means will be 0, because 0 isn't even an option, and we're 95% confident that it's within that, and 95 is pretty good. So this one says that the confidence interval does not contain 0. So this is what we want. Okay, and that's all for question 24.